Greeting viewers, FireShark welcome all its viewers in today's video. Today we will discuss about transport layer. This is the fourth layer of the TCP IP model from the top, of course. We have already discussed about three layers in our previous videos. You can check out that if you have any problem in that. So, uh, Transport layer. This is the fourth layer from the top of the TCP/IP model. The main role of the transport layer is to provide the communication services directly to the application processes running on the different hosts. The transport layer provides the logical communication between application processes running on different hosts. Although the application processes on different hosts are not physically connected, application processes use the logical communication provided by the transport layer to send the message to each other. The transport layer protocols are implemented in the end system but not in the network routers. The functions of transport layer are it facilitates the communicating host to carry on a conversation. Second, it provides an interface for the users to underlying network. Third, it can provide for a reliable connection. It can also carry out error checking, flow control and verification, which we will see in our other slides. So the computer network provide more than one protocol to the network application. For example, TCP and UDP are the two transport layer protocols that provide a different set of services to the network layer. All transport layer protocols provide multiplexing, demultiplexing services. It also provides other services such as reliable data transfer, bandwidth guarantees, and delay guarantees. So this figure shows the three protocols used by the transport layer, that is the TCP, UDP and SCTP. Now, user datagram protocol. The user datagram protocol is simpler of two standard TCP IP protocols. It is a process to process protocol that adds only port address, checksum, error control and length information to the data from the upper layer. It is a message-oriented protocol that provides a simple, reliable connection, less unacknowledged service. It is suitable for applications that do not require TCP's sequencing, error control or flow control. It is used for transmitting a small amount of uh, data where the speed of the delivery is more important than the accuracy of the delivery. Transmission Control Protocol (TCP). This protocol is used. It is a reliable connection-oriented protocol that transmits the data from one source to the destination machine without any error. A connection is established between peer entries prior to the transmission. At the sending host, TCP divides an incoming byte service stream into segments and assigns a separate sequence number to each segment. At the servicing host, TCP records the segment and sends an acknowledgement to the sender for correct recipient of the segment. TCP also manages flow control so that the fast sender not overwhelm the slow service. Stream Control Transmission Protocol (SCTP). It combines the feature of both TCP and UDP. It is a message oriented like UDP, which providing a reliable connection oriented service like TCP. It is used for telephony over the internet. So this slide shows that the each of the application in the application layer has ability to send message by using TCP or UDP. The application communicates by using either of two protocols. Both TCP and UDP will then communicate with internet protocol in the internet layer. The application can read and write to the transport layer. Therefore, we can say the communication is a two-way process. Now, service provided by the transport layer. The service provided by the transport layer are similar to those of the data link layer. The data link layer provides the service within the single network, while the transport layer provides the service across the network made of many networks. The data link layer controls the physical layer while the transport layer controls the lower layers. The service provided by transport layer protocol can be divided into 5 categories: end-to-end delivery, addressing, reliable delivery, flow control, multiplexing. We will see each of them in our next slides. End-to-end delivery. The uh, the transport layer transmits the entire message into destination. Therefore, it ensures the end-to-end delivery of entire message from source to the destination. Addressing. According to the layered model, the transport layer interacts with functions of the session layer. The transport layer provides the user address which is specified at the station or port. The port variable represents the particular TS user of specified station, known as Transport Service Access Point (TSAP). Each station has only one transport entity. The transport layer protocols need to know which upper layer protocols are communicating. Reliable delivery. Reliable delivery has 4 aspects, basically: error control, sequence control, loss control, duplication control. Error control. The primary role of reliability is error control. In reality, no transmission will be 100% error-free delivery. Therefore, transport layer protocols are designed to provide error-free transmission. Sequence control. The second aspect of the reliability is sequence control. On the sending end, the transport layer is responsible for ensuring the packets received from the upper layer can be used by the lower layer. On receiving end, it ensures the various segments of the transmission can be correctly reassembled. Loss control. Loss control is the third aspect of the reliability. The transport layer ensures all fragments of the transmission arrive at destination, not some of them. These sequence numbers allows the receiver to identify the missing segments. Duplication control. This is the fourth aspect of the reliability. The transport layer guarantees that no duplicate data arrive at the destination. Sequence numbers are used to identify the lost packet. Similarly, it allows the receiver to identify the discard duplicate segments. And the service provided by the transport layer is flow control. Flow control is nothing but it uses the sliding window protocols that makes the data transmission more efficient, as well as it controls the flow of data so that the receiver does not become overwhelmed. Sliding window protocol is a byte oriented rather than frame oriented. Multiplexing. The transport layer uses multiplexing to improve transmission efficiency. It can be in two ways: upward and downward. Upward multiplexing means multiple transport layer connection uses the same network connection. To make more cost effective, the transport layer sends several transmission bounds for the same destination along the same path. Now, downward multiplexing. This downward multiplexing means one transport layer connection uses the multiple network connections. So that's it from today's video. We will meet again with the application layer of the TCP IP model in our next video. Until then, thanks for watching.